Hello and welcome to another session in mathematics. In this session we'll be looking at differentiation, but before that let us take a review of our previous lesson. Welcome back. Today we'll be looking at minima and maxima, otherwise known as minimum value and maximum value of differentiation. Minimum and maximum value of differentiation. Okay, so that's what we call what minima and maxima. So I'll be giving us the steps even as we are solving some examples. Okay, find the maximum and minimum values of y equal to x cubed plus 3x squared minus 2. So what do? The very first step is to take the derivative of y, which will give us dy over dx, to be equal to, we differentiate this. If we differentiate this with respect to x, we have 3x squared plus 2 times 3 is 6x, then this is equal to 0, right? So at this point we have 3x squared plus 6x. So the turning point, we take what we call the turning point. That's step 2, and the turning point is the point where dy over dx is equal to 0. That's what we call turning point. The point where dy over dx is equal to what? 0. So if dy over dx is equal to 0, that means 3x squared plus 6x is equal to 0. Okay, why is it 0? We are trying to find what the values of what? X. So what next do we do here? We'll find the common terms in this. The common terms. What is common here? 3x is common, so we have 3x into x plus what? 2, such that 3x times 2 will give us 6, and this is equal to 0. So what it means is that 3x is equal to 0, or x plus 2 is equal to 0. Is that clear? At the point where 3x is equal to 0, x is equal to what? 0 over 3, or x is equal to minus 2. So we have x to be 0 divided by 3 will give us what? 0, or x is equal to what? Minus 2. So we've gotten the two values of x to be what? 0 and minus 2. Okay, first of all we consider the point where x is equal to 0. Okay, if x is equal to 0, we then say when x increases, let's say from 0 to x being equal to half, okay, then that means in our dy over dx, which is this, we have 3 into 1 over 2 squared plus 6 into 1 over what? 2, right? Okay, here we have 1 over 2 squared. 1 over 2 squared is 1 over 4, right? So 1 over 4 times 3 will give us 3 over 4, plus 6 times half will give us 3. Is that clear? So it means that we'll have our value here to be 3 whole number 3 over 4. 3 over 4, and you know this is positive, right? This is positive. Now at the point where x decreases, if x decreases from 0 to minus half, let's go back to the next page. If x decreases to, say, x equal to minus 1 over 2, okay, therefore our dy over dx would then be equal to 3 into minus 1 over 2 plus 6 into minus 1 over 2, right? This is squared, right? So we have minus 1 over 2 times minus 1 over 2, which will give us 1 over 4. 1 over 4 times 3 will still give us 3 over 4, plus minus 1 over 2 times 6 will give us minus 3. So we have minus 3. Okay, and taking the LCM, we have the LCM to be 4. 4 into itself is 1 times 3, we have 3. Here is 1. 1 into 4 is 4. 4 times minus 3 will give us minus 12. And then we'll have our answer to be 3 minus 12 will give us what? Minus 9 over 4, which is equal to minus 2 whole number 1 over 4. Okay, and this is negative. This is negative. Okay, now at x equal to 0, the function is minimum. The function is what? Minimum. The function is minimum. Why is it minimum? It is minimum because when x decreases, it gives us what? A negative number. It is maximum when s decreases and gives us what? A positive number. But when s decreases and gives us a negative number, then the function is minimum. But if the function is a positive number, then it is called what? Maximum value of what? X. Okay, at this point, s increased and gave us a positive number, and then decreased and gave us a negative number, so it is minimum. But if x decreases and gives us a positive number, then it is what? Maximum. So now we've taken the point where x is what? 0. Let's now take the point where x is what? Minus 2. X is equal to minus 2. That's the second value of x. So if x increases, if s increases from minus 2 to minus 1, x equal to minus 1. So we have our dy over dx to be equal to 3 into minus 1 squared plus 6 into minus 1, right? And this will give us minus 1 squared is 1 times 3, we have 3, plus 6 times minus 1 will give us minus what? 6, and this is minus 3. This is negative, right? This is negative. Fine. Then let us take the point where x decreases. If x decreases from minus 2, then we have x equal to minus 3. So we then have our dy over dx to be equal to 3 into minus 3 squared, right, plus 6 into minus 3. And what would that give us? We have minus 3 squared is 9 times 3, 27. We have 6 times minus 3, which will give us minus what? 18. And 27 minus 18, we have 9, which is what? Positive. Which is positive. And at this point, we say that the function is what? Is Maxima. Is maximum. Okay? Why is it maximum? Because when s decreased, it gave us what? A positive number. I said it earlier that if s decreases and gives us a negative number, it is minimum. But when it decreases and gives us a positive number, then it is what? It is maximum. Okay? So let's take one more example. Number 2. Y equal to x squared plus 6x minus 4. Our dy over dx is equal to 2x plus 6, right? Taking the turning point, that is where dy over dx is equal to 0. We have that 2x is equal to minus 6. That is, this is crossing the equality sign. X is equal to minus 6 divided by 2, which will give us minus 3. So taking s to be equal to minus 2, that is when s does what? Increases, right? So we have 2 into minus 2 plus 6, and what would that give us? Minus 4 plus 6, which is what? 2. And that's what? Positive. Okay? Then when s decreases, x will then be from minus 3 to minus 4. So we have 2 into minus 4 plus 6. Okay? And that will give us 2 times minus 4 will give us what? Minus 8 plus 6, which is what? Minus 2. And this is what? Negative. This is negative. This is positive. Okay? So, at this point, we say that what? This function is what? Is minimum. The function is what? Is minimum. Because at the point where s decreased, it gave us what? A negative number instead of what? A positive number. Okay? So, this function is what? Is minimum. So, how do we write that? We say that at x equal to minus 3, which is the value of x that we obtained here, the function y equal to x squared plus 6x minus 4 is minima. Okay, it's minima. So the value of y in this equation would then be y will be equal to minus 3 squared plus 6 into minus 3 minus 4, and this is 9 minus 18 minus 4, which is equal to what? Minus 13. Okay, so but there's another way of solving for the maximum and minimum value of a function, and we call that the second derivative test. Second derivative test. I'll just give us one example on that second derivative test. Okay, how does that work? Just bear it in mind that when we obtain d squared y over the x squared to be less than 0, then we've obtained what we call what? The maximum value. That's the maximum point. When we have d squared y over the x squared to be greater than 0, then we've obtained what? A minimum value, or a minimum point. Okay, so let's take an example to illustrate this. Assuming we are given y to be equal to s cubed minus 12x plus 2. Now our dy over dx, remember, is equal to what? 3x squared minus 12, right? Okay, at the point where dy over dx is equal to 0, that's the turning point, then 3x squared is equal to 12, and then x squared is equal to 12 over 3, which is 4, and then x is equal to the square root of, and this is plus or minus what? 4. So x is equal to plus or minus what? 2. That's the value of what? X. Okay, so since x is plus or minus 2, we substitute x to be plus or minus 2 here. Therefore y will be equal to 2 raised to power 3 minus 2 minus 12 into 2 plus 2. Y is equal to 8. Minus 12 times 2 is minus 24 plus 2. And what would that give us? Minus what? 14. So at x equals to, y is what? Equal to minus 14. So let us then check, let us then take the second derivative of this. Second derivative of this will be d squared y over the x squared. This will give us 6x. Remember, this is what we are differentiating against, 6x. So if this is 6x, then we now substitute x to be equal to what? 2. So we have 6 into 2, and that will give us what? 12. And I told us that that the minimum point is at the point where d squared y over the x squared is higher than what? 0, is greater than 0. And at this point we have 12, which is greater than 0. So this is what? Minimum. The minimum value. Okay, fine. Let us proceed. Now, if x ceases from being 2 and becomes minus 2. For instance, what will be the value of y? So we say, let's go to the next page. When x is minus 2, then y will be equal to, we have minus 2 raised to power 3 minus 12 into minus 2, then plus 2. And what would that give us? This is minus 8. Minus 12 times this will give us plus 24 plus 2. Okay, so 26 minus 8 will give us what? 18. 26 minus 8 will give us 18. So at the point where x is minus 2, then y is what? 18. Now we'll now substitute the value of what? X, which is minus 2, in our d squared y over the x squared, which is what? 6s. Remember? So we have 6 into what? Minus 2. And that will give us what? Minus 12, which is negative. I told us that the point where d squared y over the x squared is less than 0 is the maximum point. So this condition has satisfied that. So that is the maximum point. Okay, so that is how to derive minimum and maximum point using the second derivative test. So to refresh your memory on what we've just done, kindly provide the answer to the following questions on the screen. Welcome back. We'll stop here today. So do well to use the lesson note on the platform for better information on what we've just done, and feel free to drop your questions or comment on the comment section. Till we meet again, stay safe. Bye.